Today's video is on integration using residues. So in today's video, we are going to find the residues of the function f of z is equal to 1 minus e power 2z by z power 4 at the poles. See here, it is very clear that f of z is given as 1 minus e power 2z by this is z power 4. So here z is equal to 0 is a singular point. Z is equal to 0 is a singular point of f of z. And next one, expanding f of z. So we have to expand f of z. See here, expanding. So how we have to expand f of z? So f of z is equal to 1 minus e power 2z by, this is z power 4. As you have a formula for e power x. See here, since e power x can be written as 1 plus x by 1 factorial plus x square by 2 factorial plus and so on. So I am using this here, and next I am expanding. So here f of z can be written as, so f of z can be written as 1 minus. So e power x, in place of x we have 2z. So that is 1 plus, this is 2z by 1 factorial plus 2z square by 2 factorial. And next one, see here, this is 2z whole cube by 3 factorial plus and so on, divided by, this is z power 4. Clear? After expanding, see this will be f of z is equal to, see here f of z is equal to, this is 1 minus 1 minus 2z by 1 factorial into here, this is z power 4, and here also z power 4. And next one, this is minus, plus into minus, minus 2 square, this is 4 into z square by, this is 2 factorial into z power 4. Clear? Minus into plus, this is minus 2 cube, that is 8, this is z cube by 3 factorial into z power 4 minus and so on. Clear? And after expanding, so now I am cancelling these two terms. Then what remains? F of z value is equal to minus 2z by, see here, this is 1 factorial is nothing but 1, this is z power 4. Here it is 4 into, if I cancel this for 2 times, this will be 2 into this value is z square minus 8 into, if I cancel z cube. So 3 factorial is nothing but 1 into 2 into 3, that is 6 into this value is z power 4 minus and so on. See here, if I cancel each and every term, then f of z is equal to, this is minus 2 by this value is z cube, and this is 2 by, the value here is z square, minus, if I cancel in, see here 2 table, this is 4 and this is 3. This is minus 4 by 3 into 1 by z. 1 by z and so on, minus and so on. And see here, and now see here, this is pole z minus 0 power cube, and now this can be written as z is equal to 0 is a pole of order 2. So z is equal to 0 is a pole of order, see here, order 3. So pole of order 3, and therefore the highest negative power, therefore the highest negative power, highest negative power of z minus 0 is the residue value. Therefore the residue of f of z, therefore the residue of f of z at z is equal to 0 is nothing but is, so the highest power here is this one of the negative power of z minus 1 is nothing but minus 4 by 3. So this is minus 4 by 3. So this is the residue value of f of z at z is equal to 0. So this is how we have to expand, and here it is z is equal to 0 is a pole of order 3, and therefore the highest negative power of 1 by z is nothing but minus 4 by 3. So here we have to take the quotient of this one, and we have to write the residue of f of z at z is equal to 0 is minus 4 by 3. See, let me explain you once again. Here we have to find the residue of f of z is equal to 1 minus e power 2z by z power 4 at the poles. So f of z is given like this. So z is equal to 0 is a singularity or a singular point of the function f of z, and clearly expanding f of z. So we have to expand e power x in terms of 1 plus x by 1 factorial plus x by 2 factorial and so on. And after expanding and sharing this denominator to each and every term, so this remains. So this is clearly z minus 0 whole power 3. So z is equal to 0 is a pole of order 3, and therefore we have to find the residue of z minus 0. So z at 0 as the highest negative power, the quotient of the highest negative power will be the residue of the function f of z at z is equal to 0 is nothing but minus 4 by 3 is the answer. Thank you so much for watching. If you really like this video, you know what to do. Please practice and pass it on to your friends, and please go through the playlist. Definitely you can score more. Thank you so much.